Hi guys, so today is a pretty cold and rainy day out here, so I decided why don't we solve a little puzzle about two candles. Hopefully it can warm us a bit up. So we get two candles, which are the same height, but one is slightly thinner than the other. And we know that the first candle completely burns in 10 hours. The second candle completely burns in 8 hours. Now the question is, if the candles are lit at the same moment, how much time should pass in order for the first candle to be twice as high as the second candle? Feel free to pause the video, maybe try this for yourself, and make sure to write in the comments if you got it correctly. We will start by saying that we want to find the time. We will label it as x. Next, think about the first candle. If it burns in 10 hours, then it burns 1/10 of its length in 1 hour. Now we assume that it burns it at a constant rate. I hope this is pretty clear because this is a candle. So the second candle is the same. If it burns completely in 8 hours, then in 1 hour it burns 1/8 of its height. Okay. Now we want to find how much the candle burns in x hours. We just multiply this number by the amount of hours. So we get x over 10. Over here the same, x over 8. And the last thing we want to find is not how much of the candle is burned already, but how much of the candle is left. We just subtract from the whole candle the amount that burned. But what's the height of the candle? We don't know anything about it. Well, we actually do, because we wrote everything here in terms of the parts of the candle, not in meters, not in centimeters, but as the parts of the candle. Therefore, the whole candle, in terms of parts of the candles, is just 1. It's 100%, okay? One part of the candle is the whole candle. So with 1 minus x over 10 is how much of the candle is left after x hours. And the same thing here, 1 minus x over 8. We can check if we've done everything correctly if we substitute x equals 0, so no time passed. So the first and the second candle will both be just 1, just the whole candle, nothing burned, no time passed. Okay, and to double check, we can plug x is equal to 10 right here. Now it should give us that nothing is left, because in 10 hours it burns completely. And actually this is what we get, because 10 over 10 is 1, 1 minus 1 is 0. Okay, so this is true. Now, we didn't use the fact that the first candle will be twice as high as the second. Let's use it now. Let's write that the height of the first candle after x hours will be equal to the height of the second candle but multiplied by 2. And this is our equation for x that we want to solve. It is pretty simple. First we want to multiply 2 into these brackets to get 1 minus x over 10 is equal to 2 minus 2x over 8. Now 2x over 8 can be cancelled to get x over 4, right? Now I moved the equation up top here so it would be easier to write. In order to solve it, we move everything that contains x to the left hand side and everything that does not to the right hand side. So this one goes here and this minus x over 4 goes here. So we get minus x over 4 becomes x over 4 minus x over 10 is equal to 2 minus 1. 2 minus 1 is just 1. Now, these two fractions have different denominators, so in order to subtract them, we want to make them the same, which is equivalent to finding the smallest number, which is divisible by 10 and by 4. Now, I think it's pretty easy to notice that this number is 20. So we want to make this denominator equal to 20. To do this, we multiply the first term by 5 and the second term by 2. And we get 5x over 20 minus 2x over 20. is equal to 1. Now we can write everything down as one fraction. To get 5x minus 2x divided by 20 is equal to 1. 5x minus 2x is 3x divided by 20 is equal to 1. Now we multiply both sides of the equation by 20 to cancel the fraction, right? We get 3x is equal to 1 times 20, which is 20. And to find x, we only need to divide both sides by 3 to get x is equal to 20 over 3 hours, because x is time. Okay, this is already an answer, but let's quickly check if it didn't mess anything up. In order to do it, we just plug the time that we just found over here to find the height of the first candle and the height of the second candle, and we check if the first candle is really twice as high as the second one. So for the first candle we get 1 minus 20 over 3, which is x, divided by 10, I'm going to write as 1 over 10, multiplied by 1 over 10. Cancel the 10 to get 2 and 1, which gives us 1 minus 2 over 3, which gives us 3 over 3 minus 2 over 3, which is 1 over 3. And this is the height of the first candle. Okay, for the second candle, everything quite similar. Write this down. Now cancel the 4, which gives us 2 over here and 5 over here, which gives us 5 times 1 is 5 and 2 times 3 is 6. Now 1 is equal to 6 over 6 minus 5 over 6, and we get 1 over 6, which is the height of the second candle. And we can see from here that our solution was right, because the first candle is twice as high as the second candle. Now we don't know in meters what is the height of the first and second candle, but we know in parts, and we from this conclude that the first candle is twice as high, because they started at the same height. Now, the last thing that I want to do is to rewrite this answer more clearly, because nobody expresses hours in fractions, okay? So 20 over 3 is just 6 and 2/3. What is 2/3 of 1 hour? Well, it's just 40 minutes. So the answer is 6 hours and 40 minutes. That's all for today. If you like the solution and if you like the puzzle, please leave a like, leave a comment, subscribe to the channel, and bye.